Our second to last video is on energy flow and this 10% rule. This was awesome coincidence, by the way, that 1.10 is on the 10% rule. It's going to have a little bit of math, but not that bad. So the goal of this is to determine how the energy decreases as it flows through ecosystems. The 10% rule says that with each transfer of energy from one trophic level to the next, you only have about 10% of usable energy passed on. So when we talk about usable energy, what that means is energy that is left over after, for instance, metabolism, after the energy it took to go catch that food or whatever. At all these steps, you're having these molecules broken apart and the cool cell things happening, and it's releasing heat. So we can't use that energy again. We can't absorb that heat and use it to put together our ATP again. So the 10% is what actually is left over to become part of you. When a grasshopper eats a leaf, the energy left over to become part of a grasshopper. So it's very simple math. With each step up the food chain, you just multiply by 10%. You know, primary consumers always have the most amount of energy because they're the ones doing the photosynthesis and making all that biomass. And then with the primary consumers, they only get 10%. And then the secondary consumers only get 10%. Tertiary consumers, 10%. Quaternary consumers, 10%. So it's fairly simple math. But the big takeaway from this is that's why if you're higher in the food chain, you have to eat so much. Because what's left over, you don't get a lot of usable energy, and you get a lot more energy if you eat lower on the food chain. That's why, eating your vegetables, important thing, guys, because you're getting more energy because of the 10% rule. Remember though, none of that energy is going away. It's not just poofing away. We still have energy moving all around the universe, the same amount, but what's going on is that energy just isn't good energy anymore. So the first law of thermodynamics says that you always have the same amount of energy. The second law of thermodynamics says that the quality of energy tends to, or reduces with every change. So this is also called entropy, if you've taken physics or remember this from a random science class or whatever. Entropy is the amount of disorder. So with every single chemical reaction, or whatever it is, disorder is always going to be created. So you're always going to have more energy bits, I guess you could say, but it's all going to be crappier energy. Alright, as a summary, determine how the energy decreases as it flows through the ecosystems.